What's up, team? Today we're going to talk about three theorems centered around chords. Now, with these three theorems, a couple things I want to say at the front end. I gave them names, arbitrary names. Theorem 1, Theorem 2, Theorem 3. If you get on the Google machine and you type in Chord Theorem number 1, this is probably not what's going to pop up. I don't have like the technical names. I just arbitrarily name them for the sake of this lesson. So don't expect these to be official names. Second, I'm not going to walk through all the proofs of these. Proofs exist, I can assure you. We can talk about it when we're together, but in this video I'm just going to talk about what the theorem says and maybe how to apply it a little bit, although when you run into these situations out in the wild, the application of them is going to look different depending on context. So I can't go through every possible scenario because there are infinitely many scenarios. Okay, let's talk through these and try to make sense of these different theorems. So first, chord theorem number 1, as I've named it, if a diameter is perpendicular to another chord, then the diameter bisects the chord. So an example of that, here's a circle. I have a diameter AB, and it's given that this is perpendicular to chord CD. That's the assumption. So if you run into a scenario where you have a diameter and it is perpendicular to CD, let's actually mark that in here. So that's not something we forced to happen. It's something we kind of stumbled across. If you stumble across that, then you can definitely say that CE, oh, I should have named this, yikes. That's point E, where they intersect. So CE and DE are congruent. So they have the exact same length. So again, a diameter is perpendicular to some chord. That means that chord is being chopped in half into two equal segments. There it is, chord theorem number 1. These are definitely things I don't expect you to memorize. Maybe have them handy, maybe be familiar with them. For this one, I don't have it memorized, but I know if a chord and a diameter, a chord and a diameter are perpendicular, I know that means something. So I flipped in my notes, I look for these theorems, and I'm like, oh yeah, that's what it means. So kind of be familiar with that idea. Okay, chord theorem number 2. If two chords are congruent, then they are equidistant from the center. Lots of words here. Equidistant means the exact same distance, equal, distant, from the center of the circle. So for example, if we know that chord AB and chord CD have the exact same length, and in this case we don't know what the length is, we don't really care, we just know that they're the same, then the outcome of that is that this segment EG and FG are the exact same length. G is the center of our circle, so we are saying that the shortest distance from the center of the circle to our chord, which ends up being perpendicular for both of these, the claim here is that these two segments are the exact same length. So if you're out in the wild looking at circles and you find that a circle has two chords within it that are the exact same length, they are congruent, then you can absolutely say or draw the conclusion that they are the same distance away from the center of the circle. Again, in this case, EG and FG have the exact same length. Okay, that's chord theorem number 2. Let's bounce to number 3, a third and final theorem of the lesson. If chord AB and chord CD intersect at point X, pause. We know nothing about the lengths of these two chords. They don't have to be the same length. One can be longer than the other. It doesn't matter. There are two chords that cross each other, and we name the point X. So if that's the case, then the product of AX and BX is the same as the product of CX and DX. Yikes, all of a sudden we're doing algebra. So let's look at an example of what's going on here. This one I even attach numbers to just to make sure it makes sense. So given that AB and CD are chords, that's all we know, they're chords. And then they intersect here at X. So AB is here, it has length 17. CD is here, it has length 19, if you add those two together. Well, the outcome of this, or what this theorem is saying, is that AX, this 7, so actually, let's put this in. We're saying AX, which we know is 7, times BX, which we know is 10, equals the product of CX, which is 5, and DX, which is 14. Well, we can confirm this pretty quick. We know 7 times 10 is 70, and in the same way, 5 times 14, well, I know 5 times 10 is 50, and then 5 times 4 is 20. 50 plus 20, you smash them together, and you get 70. So this is a pretty powerful one that I think you'll run into more than the other two. That's just kind of a gut feeling. Whenever you have two chords that cross each other, the product of the two segments of that chord has to equal the product of the two segments of the second chord. So it feels kind of wonky, feels kind of weird, but it's a pretty powerful little theorem here. Okay, here's some theorems about chords. These are going to be mixed into practice problems. So it's going to be, you're going to be doing other things. Like within these, you're going to have to do some Pythagorean theorem. You're going to have to, you might even have to do some trig stuff inside of these circles, triangles of form based on these theorems. So it's not, none of these are step by step. Picture these as kind of tools to add to your tool belt that you'll use sparingly. You'll use them sometimes. And you just kind of got to figure out, based on the information you have, when can I use these? Can I even use these? Maybe I can use two of these, but not the third one, or something like that. So it depends on the information you have. These just take reps, they take practice, they take hard work, they take failure. You're gonna try a bunch, you're gonna fail a bunch, and that's okay. Get back up, try again, and be okay with that. That's part of them. That's where you're at in your math journey at this point in time. So here are three new tools to add to your tool belt: chord theorems 1, 2, and 3, as I've named them. Let's look into some practice problems. Let me know if you have questions. You got this.